Hi, I'm Barnabas, and in this tutorial, I'm going to show you how to make objects, shape layers actually, move radially outwards in After Effects. Now, in this tutorial, you learn how position actually works, and because it may be a little bit confusing, also you learn how to use expressions to actually solve any problem, like any problem you want to I'm just going to briefly show you some examples of projects done by big studios that use this particular tip that I want to show you. So I'm just going to I'll leave all the link to those videos in my description, so you could go and check them after you're done with this video. So the first one is
John lives in Coventry.
by
John also drives a polluting older car. He
I've
loves having his own
forgotten
car.
the studio that
It
did
takes him
this.
places.
Oh, I checked this on motionographer.com. Sorry, let me replay this.
John lives in car, but John knows his
I'll pay
commute adds up.
attention.
That got him thinking about the
Almost there.
mobility credits list.
Move
Registered
this a
at your
little
name,
bit
get
forward.
mobility credits in return. And after spending a lot to be part of the trial initiative, and he's received his
Look at
mobility
this.
credits.
Look at this.
With these credits, John can pay for any local bus or train journey, or even buy a
Forward
season
it a
that's
little
quick
bit.
and simple. All managed via an
Look at
easy-to-use
that.
app.
See
So
how
now,
cool that
with
is?
mobility
And I'll
credits,
show you
John can travel whichever way he
next
chooses in an
one. Let's get ready to apply. Yeah, this one. So pay attention. No audio. Sorry, no audio. I just want you to see how this cool stuff are being used. Now look at that. Look at the ending, like close to the end. Now look at that. Now so when you want to do this kind of stuff, in After Effects, the wrong way to actually do this is to I'm sure I'm just going to open After Effects, and I'm going to close this tab over here. Then I already made a composition. This composition, I'll press Ctrl K to or Command K on your Mac. If you now notice that my composition is on 1080 by 1080, basically a square. So I already made the style frame, which is available for you to download in the link in the description. I'm going to go ahead to import my file, which is an AI file, and 10 local disk, and let me show you practice. Sorry, I have to take you through this. Then style frame, right? Want to import, then import as a composition, then footage dimensions, just click on OK. So I'm going to bring in the composition here, and wow, we already have this. Now if I go ahead to click into this composition, you can see that all of my layers are there intact. Now as I was going to say, now the wrong way to actually do this is to say you are going to actually have to like do each shape layers. You are going to actually like animate them individually. Now there are a couple of reasons why this is going to be wrong, and number one is that it's tedious. Let me go ahead to turn on continuously rasterize, so this does not pixelate as I'm zooming. Okay, Still doing that. Full. Okay, that's better. So look at this. Now let's say for example we want to animate this and we want it to move, let's say, in that direction. Now how do we like keep moving all these single elements into like doing that? Not that it's not doable, it is doable, but it's going to take a lot of time and effort. Now another reason why this is not the best is can also be very inaccurate. For example, you want to ensure that the particular shape layers are actually moving at a proper degree, like angle, in which it makes sense for them to move. So if you are doing this manually, you will have to like use your sense to calculate, and it may really lead to uh, very ugly animation. So that's why you have to be careful. um, um, there is a right way to doing this, and that's by using expressions. And one way expressions is going to actually like save you a lot distress is you know it's actually less tedious, and you're going to learn a lot of things doing it the expression way. You're going to be learning basically what's going on in After Effects better. Then also it's reusable, so you don't have to keep doing all this radial you know you know manually, like having to animate each particular positions every time. Once you're able to like make an expression for this, you could reuse the code in any you know project you're actually working on anytime. So instead of actually having to manually animate the position of this shape layers, you have to like you just have to copy and paste, and it actually saves you a lot of time. So it's actually reusable. So I'm just going to go ahead to show you how this is done. I'm going to press on Control A or Command A on the PC, on Mac rather. Then I'm going to make this into shape layers. Then I'm going to move them a little bit upward, I mean in the layer panel. So that's by pressing Control Shift and the bracket, close bracket. So I'm going to go ahead to delete my AI files. Yeah. Now so here we are with this. Then so how do we make these things move? Now one thing is that if we click on an old let's say I select all of this, each and every single one of these have their position, and it's one thing that we all need to understand. What exactly is position? What exactly is position? And position is not something that is just what you have in After Effects. Is something that actually exists in real life. And After Effects wasn't created really from it's from things that actually happen in real life, like the real life sense of position, and that's what led to programming and led to all of these things. So mathematics, I know if you're not a a good student of mathematics, you don't have to get scared, because I'm about to show you how position actually works in real life. So let's leave this for a little bit of time, and let me show you what position is, it really is in real life. Now before we go to see some of the cool stuff that I have to show you, Let me are we done? I already have all the layers selected, so I'm going to hit on P. It's going to show me all the position parameters. Now, here's one thing you need to understand, that in After Effects, when you have position of any shape layer, what it returns is, in real life, position actually is a vector quantity, and when you say something is a vector quantity, it means that particular um, um, quantity actually doesn't only have magnitude, it also has direction. And so because it's has both magnitude and direction, After Effects doesn't relate with it as just values. It actually relates with it as vectors, and therefore they are in arrays. Now arrays is more like you're having matrices, and it's just a way to actually represent vectors. So that means that whenever you are dealing with position, particularly when you have not separated the dimensions in After Effects, you would have to relate with them in as an array. For example, let me just click on this one over here. I'm going to press on Ctrl Shift A or Command Shift A on the Mac. Then I'm going to click on this. Now, for example, I'm going to hold Alt or Option on the Mac. Click on Position here, the stopwatch. Then I'm going to show you something. If you, for example, type okay x equals, I could just go ahead to say x equals to this property dot this property semicolon, and now here's one thing you want to take note of. For example, what happens is that uh, for any vector quantity, really um, there's this operation that you can perform with vector quantities by you know it's called dot product, and After Effects by can actually allows you to make these operations on any vector quantity. So I want to just quickly show you something. Now, if you don't understand any of this, you don't have to bother yourself about it. Just know it. You could go and research about it if you want to, which I really advise that you do, because it's going to actually help your journey as a motion graphic designer. So I'm just going to show you something about this now. So what happens is that once I've written this expression x equals to this property, x is a variable, so it means that it can take in any value that that I equated to, like I've said x equals this property semicolon. That means that what we're going to find in x now is going to be the property, which is the value of this property, which is going to be the position of that layer in space. I mean, the space in After Effects now, which is our composition. So it's going to return the position. What it's is going to be contained in this variable now is the position of the that rectangle in time. So I'm just going to it's what's basically is going to be found in this array now is going to be this x. After Effects is going to return an array, because as I said, position is actually a vector quantity in real life. That means that there is always a direction to position relative to a particular origin. Now direction is not it's not general, like it's always relative to something. So we all know that there are different directions. Now, all of these shape layers are actually facing different directions. So, if they were to move radially outwards, they would move in different directions. So, one thing we want to do is we want to know, their directions, and we want them to continue in that same direction, moving in a move a certain distance in the same direction. So, that's just that. So I just want to show you that this is going to return an array. So um, let's so I'm just going to like say x equals to and 0 comma 0, yeah, let's say 6 comma 6, right? So what this is going to do for me is that once this runs, it's going to like, oh, sorry about that. So what this is going to do is that it's going to make the value of my shape layer is going to like return, is going to be 6 along the x-axis, and then 6 along the y-axis, in my comp. Now I'm going to show you everything in a moment. Now, so let's run this. I'm coming. Let me just confuse that. Now look at instantly, you can see that both 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 values of my position has changed to 6, and it's red now, so that means I can't really change it. So even though I scrub, it's going to still go back to 6 by 6. So I'm just going to alt or option click on this position button again to just leave that. So we know there are ways by which you can actually deal with those particular positions individually, but without separating the dimensions, you're going to have a lot of difficulty. I tried it out and found out that it's not going to work that way. So let's say you're watching this tutorial and you want to kind of like exploit, then you can actually, and do post it on social media and tag me. um, 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 my handle is in the description, so you could tag me, and then I'll check out your work and reshare, because it's going to be awesome for me to like, it's going to actually have rather lots of insights. So I'm just going to go ahead to show you how position really works, for some of us that do not understand. So I'll leave the description to all these files I'm using below, so you could actually go to grab them now. So let's go ahead. This is Illustrator, so I made all these funny graphs of how position is now. So this is the way position is in real life. For example, anytime you see let me go back to After Effects for a little bit of time to show you some of these things. Now look at this. There is the position. This is the x position on the x-axis, and this position on the y-axis. That means if you scrub, okay, which one am I scrubbing now? Let's see. Let me reduce this. Okay, that's the one I'm selecting. I'm going to press Ctrl Z, right? So I'm just going to click on this, right? Let me just click on anyone. This, okay, yeah, this. Hit down P, and by the time you see I'm scrubbing, now you see it's only moving horizontally. I'm sorry, if I scrub that way, it's going to only move vertically. And what does that mean? Now let's go back to our graph, and you see conventionally two-dimensional, all the movement that you see that I've performed is only two-dimensional, and two-dimensional means you are actually only moving in two directions, either vertical or horizontal, or both. Now, so it means you're not traveling, like you're not moving, you're only moving in that direction, not like you're not moving outwards of it, let's just leave that for another time. Now, so let's say for example, you have an object, you know moving, let's say, so any object that you basically have, moving, or that occupies any position really in space, particularly within After Effects. Now let's treat this as our comp. After Effects comp, this white space that is selected, that you have the blue outlines around, let's treat this as our comp. So let's say, this is um our particular object in After Effects, and let's say, let's say this is where um, our origin is. Now, origin in position is really nothing. It could be anywhere. Origin is, because really in real life there's no origin. What's you can only define origin relative to a particular thing. So for example, this in After Effects, in real life actually could be, the origin could just be a particular person, and you're measuring the position of a person relative to another person. So like, let's say for example, I'm here in Nigeria, and you are there, let's say wherever, let's say you're in Brazil or anywhere. So like, if I'm going to measure my position, there's no particular origin. The origin is relative. So the moment you are measuring your position relative to me, then I become the origin of I become the origin. So that means, like, I'm basically 0,0, and wherever you are, you are, this everything is being measured relative to that. So that's that. So let's say in After Effects. Now After Effects, there the points in our composition really, the point that is 0,0 in our composition is usually on the top. Let me quickly show you that. Look at this. For example, now I'm going to change this, the position of this to 0. I'm going to change this also to 0. Now notice I'm going to press enter. Now where is our, okay, now look at our rectangle right here. See where it is. So that means the point that is 0,0 really in our After Effects file, it's this particular edge, and that's why you can actually see that the anchor point is actually snapped to that particular point. I'm just going to click tap Ctrl Z twice to actually bring my rectangle back in place. So needless to say, we're not going to use that. Why? Because if it's going to be moving radially outwards, then the center really actually has to be the center of our comp here. So that means we're not going to use the point 0,0 in our After Effects composition. We want to use the center of our comp. And before I go to actually show you all of that, let me just go ahead to actually start showing you all of this now. So look at this. So that's to actually make the center of our comp. You want to make the center of the comp, we want to make it the origin. So here's what we're going to do. I'm just going to right click on an empty space right here, and I'm going to like click on new, and I'm going to choose a null object. So if you didn't get that, you could actually go to layer up here and click on new, and then click on null object. You can see the shortcut is Ctrl Alt Shift Y, which is Command Option Shift Y on the Mac. So now look at that. All of are found. Now, so the null is actually in the center of the comp by default. So, and that's actually like, if you check the position, which is 540 by 540 540, that means that that's actually like dividing 1080 by 1080, dividing it into two, that's like 540 by 540. So that's the reason why the position is actually there. I'm going to close this. Now that we have the null object in the center, so we want every of our position to actually be relative to that null object which is at the center. So the null object which is at the center of the comp is now our origin. So we want to every position, every other position, we want to actually measure it relative to that center of comp. Now note that After Effects is not measuring our position of any shape layer in this composition. It's not measuring them relative to the center. It's measuring them relative to this point over here. This is the point 0,0. So basically this is where our x-axis, which is the horizontal axis, actually starts from. This is where our vertical axis actually starts from. So I'll show you that in a moment. So it's basically just looks like this. Now it's a little bit different. Look at this, for example. I just want to show you this. Now forget about any other thing I can actually see here. So it's more like this. So you see that this is the x-axis, and then this is the y-axis. That's how it always is in a two-dimensional world. It's only horizontal and vertical. So that means that just like the way you have it in After Effects. So moving one, yeah, with this as origin, it's just the kind of way it actually is in After Effects. So everything actually starts counting from the center and then downwards. I hope you actually get. So so that point there is 0,0, and everything start counting downwards. That shows us something which you really need to think about. It's that in After Effects you find that it's not because usually in real life position system, like there is a convention that we have, and if you see this, you see plus y-axis plus x-axis, negative y-axis, negative x-axis. That means that anytime you cross the line of the origin 0,0 and you start moving below that, what you have is a negative value of the y-axis. For example, let's say you have an object that is, let's say here, for example, I'm going to alt click on this to drag this here, and so let's say we have an object that is actually in this direction. So you are not going to like in the direction. Now the point here is let's say this is on 4 to avoid several problems. Now this is 1, it's going to be in the negative. Pardon me for all this mistake I made. Okay, I'm just going to show you this. Now look at that. So it's going to be negative. Negative. So that means whenever you are moving downwards below the origin, what happens below 0, that means you already be counting in the negative. anything beyond zero is in the negative. So anything above zero is in the positive. It's positive. So that means for example, if the origin, for example, let's say I'm standing here, right there, and and another person's position is to be measured relative to me. In a normal Cartesian coordinates, which is just basically x and y axis, which is like a norm, when dealing with 2D dimension. It's that, look at this. So the moment we're using Cartesian coordinates, which is what I'm using now, the moment a person is like in this position relative to me, what we have is, you can't say, for example, I'm on, 4. Uh, this is like saying I've moved 4 on the x-axis. That's in After Effects going to be like 4.0, then space, then then another 4.0. Now notice the difference. In real life Cartesian coordinate system, it's going to be 4 comma minus 4, but in After Effects it's not going to be that. It's going to be 4. Let me show you that. It's going to be 4 let me show you. Okay, it's going to, let me just go back to this to show you. In After Effects is not, After Effects is not going to read this as negative. It's going to read this as positive. Why? Because After Effects is not running that kind of normal Cartesian coordinates. Now let's say, for example, an object in After Effects, you move upwards beyond those point of this 0, which is actually quite which is here. After Effects begins to read this as negative. So you begin to move upwards, that's beyond the 0, mark, whether you are moving towards the x direction, which is like this, or towards the y direction. Either direction is actually on the negative. It's on the negative. So that means whenever you are moving downwards, it's positive. Whenever you are moving upwards, is negative. Whenever you are moving towards the x axis, it's you are moving in the negative. Moving towards this direction. If you are seeing the mouse, it's negative. When you are moving upwards, is also negative. When you are moving downwards, is positive. When you are moving towards this direction, is also positive. So you have to bear that in mind. So that's the way After Effects, it's different from from the normal Cartesian coordinate. So I'm just going to show you this. So now, yes, our normal the typical way things are in After Effects. I'm just going to show you this, and from there we calculate how things are going to run, because we want our expressions to actually be well planned. Because if you don't plan your expressions well, you're going to end up in trouble, real trouble, because it's going to give you a lot of stress before you can actually finally fix it. So you want to have it planned well, and so that you can just from there write your code and make it as robust as possible to accommodate any error that may want to happen. Then so you don't have troubles later on when you are animating your when you are coding your well, yeah, putting in your expressions in After Effects. So I'll just quickly show you what it means for something to travel radially outwards. Now pardon my use of the word radially outwards. What I mean is that for it an object to keep the same direction. So for example, we want our object here. Let me use this as an example. Let's say we have this now. um we have this object that is here. We want our objects, when it's moving, we don't want it to move in this direction. No, we don't want it to move in uh, this direction, from here to here. No, we want it to move in this direction along the same path that it's moving. Let's say we're calculating from the center of the comp. So basically, this is what we have. It's like let me do this. Sorry. Now this is what we have. Like, I'm going to go ahead to create with the pen tool. Okay, and I'm going to align this center, Windows align. Then I'm going to bring this to center of composition. So that's that. I just hope I didn't. Yep. Okay, so we have that. So I'm also going to press Ctrl D. Then I'm going to rotate that by 90 degrees. Okay, sorry, that's a mistake. By 90 degrees. Now, so my layer is invisible. That's because my stroke is okay. I'm going to leave it on 4 so that I see what's going on. So I'm just going to zoom in. Oh, sorry, Ctrl Z. Then I'm going to zoom in for you to see now. So here's what's happening. So let's say we have these objects that relative to the center of the comp. You find that, let's say, this is where the anchor point of this particular object is. We want this particular object to keep moving in this direction, that is in next the direction relative to the center of origin. We want it to keep moving in that direction. So that's exactly what we're talking about. So this object here too, I'm just going to press on Ctrl Shift A, then, which is Command Shift A on the Mac. Then, for example, let's say this is the center of the comp of this. I'm just going to scrub this to make it visible. Now, so we want it to keep moving in that direction. Same for this object, same for every object. And now, so that's what exactly I mean by moving radially outward. So we just want it to like move in that direction that it's already moving. Now, this may be a little bit tricky because you may want to say, okay, you want this particular one to actually move, upwards. I know, but see, for the sake of this project, I want every single one of them to move radially outward. You could create an exception for some of the shape layers that you actually have in your own project, but I just want to show you how to do this in After Effects. Now, so basically, so bearing in mind, if this center is actually going to be our new origin, that is, every position is going to be relative to that. We have to bear in mind that After Effects actually still calculates based on the abnormal Cartesian coordinate, as I explained. So that means After Effects sees going down as positive, whilst it sees going up as negative. Like it's subtracting instead of adding. So when you're going to the left, sees that you're subtracting from the x, in the x direction, to the when you're moving to the y direction, it actually sees it as as though you are adding like positive, which is the x axis is actually like the same with the normal Cartesian coordinates. It's only the y-axis, those horizontal, that it's flipped. Like in normal Cartesian coordinates, should be positive. Moving in this direction is going to be positive, but in After Effects it's not like that. So that's exactly that. So having said that, we want to quickly ensure that we calculate what is going to mean for us for it to happen that a an object should move in that direction. I'll show you this. Okay, so let's say for example an object um for example moves from here to here. Now how do we calculate for this in our expression? Now it's so important that we first get this figured out before we even write any expression. Why? Because before you write, writing expressions is just like programming. So you want to actually ensure that you figure out the algorithm before you actually make any move, so you don't get all this, you don't keep moving around the circle. So now what does it mean to actually have an object move in this direction? Now when an object is moving, what you have in terms of position, now it starts in the Cartesian coordinates, which is basically like similar to the way After Effects position is. The only difference is just in where the negative is and the positive is on the y-axis. Hope we all get that. So looking at this position, if an object is actually moving in this it moves from here to here, what can we say has happened? Now notice that every when you are dealing with position, it's just like um, position cannot only be represented based on horizontal and vertical. It's also represented through angles and radius rather. So that means that for example, from here to here, I've named from here to here P. Don't mind the way things are over here. So now this is R now, which is short form for radius. Now so this is the initial radius. This is the initial radius for this. Now there's a way to actually calculate for this, which is basically like calculating for an hypotenuse of a triangle. If you know this mathematical stuff, but which you simply calculate by the formula that is shown on your screen right now. What you want to do is you want this particular object to keep moving at this tangent. And how do you do that? How do we do that? One thing is the only way we can actually ensure that our object actually keeps moving in that direction is by using, instead of the Cartesian the x-axis, y-axis, is by using this angle degree here. There is a simple mathematical expression which I'm going to endeavor to type on the screen now, which is that for example, you have this now let me increase the font size. I'm going to type let's see. Now notice that this is Y, this is R, this is A, and oh sorry, I made a mistake here. This should be B. Sorry. Okay, so let me create another text here. Sorry. So this is this distance x and y, and this distance a and b are related by a symbol mathematics like algebra, which is x over y over x really. equals equals uh, b over a, right? Okay, a over b, right? Vertical over horizontal, that was vertical over horizontal equals vertical over horizontal. So that was like, for it to happen that an object is going to keep moving at the same angle, it has to be that the tangent of this angle, because in when you're having like a this movement is basically actually forms like a right angle triangle. It basically forms like a right angle triangle, and when you have a right angle triangle, what's basically happening is that the ratio of the you know hypotenuse of the adjacent side, which is this side. How do you know which side is the adjacent? The side that is the adjacent is the one that it's under. Okay, let's take it a different way. The opposite, which is y, you know which is like the vertical axis, is the one directly facing the you know this angle thing right here. Do you understand? So you can see my mouse there right now. So the one that is adjacent is just the one that is underneath it. So that's like our x-axis. Now for it to happen that um the position, we're going to actually keep the same angle of movement, of movement really, in this sense. This particular ratio has to be kept. That is, um, um, this particular ratio has to be kept. That means the angle, that we have here, the angle that is, if we're speaking in terms of radius now, not speaking in terms of x and y axis, the it's still going to have the same angle relative to the horizontal axis. I hope we can get that. Let's say we draw a straight line from wherever our object is to the origin, right? We can get that. Can't get that. So let's say you draw the a straight line, this straight line from your object, the new location of your object, to the origin. Do you understand? Now, if you, let's say, place a compass on this, on this point, the angle you would read still has to be the same angle you read when the object was still or shape layer, anything was still at this particular point, which is 4,4, like you get what I'm trying to say. um so if you place your compass here, the angle still has to be the same. It has to be the same. If you don't know what a compass is, I mean, in your mathematical set, you could Google that, and you find a good result. So so compass, putting a compass there, it's going to give you the same degree, you know, either ways, either of the position. So for that to happen, that means this ratio of y over x has to be the same as ratio of a over b. Why does that have to happen? That has to happen because anytime you have a right angle triangle, now when you say something is a right angle triangle, it means that one of the angles in that kind of triangle has is a 90 degree, and here we actually have a 90 degree, which is here, which is the angle that our x-axis actually makes with the y-axis. In maths you would have something that looks like this. Just gonna press shift, something that looks like that, right there. Why? Because this angle right here is 90 degrees, so therefore it's a right angle triangle. So anytime you have a right angle triangle, the tangent of the angle of this particular angle in a right angle triangle is always equal to the ratio of the opposite over the adjacent, y over x. Do you understand? So that's the way it is. Then it has to be the same. So now to get this degree, like to so basically, if the same angle is the same for this, then it means that the tangent of this angle still has to basically remain the same, which is a over b. Now tangent is like a function, like a mathematical function that if you find the tangent of a particular angle, it's going to give a particular number. Do you understand? So the tangent of this particular angle, or any angle facing the right angle triangle in this manner, in as we have in this 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 file that I'm showing you right now. Any angle actually facing it in that manner, the tangent of it would always be equal to the ratio of the opposite over the adjacent, which is going to be y over x. So that tangent, since we have the same degree, the tangent, notice that the tangent is still going to be the same. So notice that it's the same thing that we have here. It's the same thing that we have here. So the tangent has to still be the same for this. So it's still going to be a over b. Now it's not like I didn't invent this. This is mathematical. It's always happens in real life. So if you want to test this out, you can get a graph sheet, and kind of like draw what I have over here. To get a graph sheet and do it, and plot your y-axis, x-axis, and measure. Just you could do just exactly what you have in this this graph, and put it directly on a graph sheet, and measure. Okay, this is practical actually. Now look at this. This is like 4.0, and this is 4.0, which is also 4 on the x-axis, right? And that's the reason why you have 4, 4 now. So if we divide this 4 4 divided by 4 divided by 4, which is 1, right? Now okay, so this is approximately 5.8, 5.8 actually, because it's just because of some mishaps in my file. So this is approximately 5.8. I just now, so 5.8 divided by 5.8 is still the same one. Do you get what I'm trying to say? So the 5.8, which is the distance from this place to this place, which is basically what you have on this side, 0 to this place is 5.8, right? So from this place to this place is also 5.8. So 5.8 divided by that same 5.8 will give you 1. Do you understand? So the tangent, which is y over x, 4 divided by 4, still the same as 5 divided by 5.8. Yeah, still the same 1. It's basically the same ratio. Do you understand? So that's basically what it is. Now, so what we want to do is that we want to, after getting this, then we have this ratio here, y over x equals a over b, and okay, so now there is another thing we want to do. Now that's that coming here, what we also want to be able to do is that we want to really be able to calculate, let's say we have a corresponding move along the x-axis, we have a move along the y-axis. How we are going to be able to animate this, write an expression for this in After Effects, is by it's by showing a correspondence. It's by we want our object to actually move a particular direction the moment our value, the x value, or I mean the position in the x-axis or y-axis actually changes. If for this case of this tutorial, I'm going to pick the x-axis. So we want there to be a correspondence moving with through our expression. If let's say for example we move, let's say as we have here 1.8 units pixels in After Effects. Let's say we move 1.8 pixels away from our initial point. We want there to be a correspondent 1.8 increase in our 1.8 increase in our y-axis, such that when we're animating the x-axis moving from this point to this point, what would happen is that we are going to actually have a correspondent increase in y-axis automatically. That's going to be calculated based on whatever angle our shape layer is, the anchor point our shape layer is relative to the origin, which is going to be the null object in After Effects. So let me show you that again. In After Effects, look at this. So this is what we want to do. We want this object that is right here, the anchor point, want it to keep moving. Let's say for example we move this in the x direction, which is like in this way my mouse is moving. Want our After Effects to calculate automatically the movement on the y-axis that is going to actually still make the angle that the object, this particular rectangle, rounded rectangle, is initially, to maintain that balance. I hope you actually get that. So in the next video I'm actually going to move on to writing the expression. So I hope you actually understood everything I explained in this tutorial. I'm going to leave the link to my social media accounts in the description below. So if you have any question as regarding the mathematics of this, you could actually ask me personally on any of this any question in my social media. And if any questions, really, you could actually ask me on my social media. So I hope you do have a good day. Hope to see you in the next video. Ensure that you actually like this video if you do like the content, and subscribe. Hit the notification bell so you could actually see when the next video comes out. See ya.